Welcome to Unit 11 on weather. And we're going to start off with our weather unit by talking about air masses, which are big clumps of air. And eventually, by the end of this unit, hopefully you'll be able to look at a weather map that you might see on TV or on weather.com or something and be able to predict what you would expect to see happening in the next few days, kind of like the people on TV do. I mean, they're more sophisticated and they have a better chance of being right than we do, but we'll get the basics of it. I'm going to start by talking about what an air mass is. Alright, and if you think about it, as you go around the Earth, there's different air pressures. And that's because the surface of the Earth is not heated equally. Different parts of the Earth get more sunlight and therefore heat more evenly or less evenly than others. So where we are, we get more sunlight in the summer, so the Earth heats more in the summer, in our summer months. Whereas someplace closer to the equator gets the same amount of sunlight all year round and heats relatively evenly throughout the year. So the regions around the equator get more energy and they get hotter. Okay, they receive more solar energy as the whole years go on, or as the year goes on, and as air gets hotter, air is less dense, so the air rises. Alright? Cold air near the poles sinks because it's cold, and it does not get as much solar energy. Alright? So up around the equator, we have low pressure centers. And around the poles, where it's cold, we have high pressure centers. And so air will move from high pressure to low pressure. And these differences in pressure create global wind patterns, or certain wind patterns. And wind goes from high pressure to low pressure. All right, if you fill a balloon up with air and then release the little part you were blowing into, the air leaves that balloon. There is a higher pressure in the balloon than the surrounding air, and it leaves the balloon until it reaches a balanced state of equilibrium with the room the balloon is in. Same kind of thing happens on Earth, is you got air moving from high pressure to low pressure all the time. So, if we think about this, if air moves from high pressure to low pressure, we think about the world where high pressure is at the poles and low pressure is at the equator, we should see a general movement of air, surface air, from the poles to the equator. Because of all this, and the temperature and pressure differences, we see three general wind belts in each hemisphere, 3 in the north, 3 in the south. And a funny little thing called the Coriolis effect causes the winds to deflect, or to turn, as Earth rotates, and that also influences wind pattern. In the northern hemisphere, things turn clockwise. In the southern hemisphere, things turn counterclockwise or anti-clockwise. And you kind of see this when you flush the toilet. Alright, the reason the water spins as it goes down the drain is because of the Earth's rotation. If you're in Australia, the toilets flush, the water swirls around the toilet bowl the opposite way. It's kind of a cool thing to see down there. So an air mass is a large body of air. And it's a large body of air where the temperature and moisture content are similar. Alright, so this whole air mass, this big chunk of air, is pretty much similar in temperature and humidity. And if we have air masses near each other where the differences are small, the air remains pretty stationary. There's very little wind, very little movement of air. All right, and so if we have a stationary air mass, or we have air moving very slow or kind of staying put over one area, it takes on the characteristics of that region. So if you have a chunk of air over a desert, that air is going to get very hot and very dry, very warm, very dry air. If you have a chunk of air over a tropical ocean or the Caribbean and just kind of sitting there, it's going to be hot and moist, hot and humid. If you have air sitting over the tundra, it's probably going to be be cold and dry. And if you have air sitting over the North Atlantic Ocean, it's over water, so it would be humid, but it's up in a polar region, and so that means it would be cold. So air masses from frozen polar regions are cold and dry. Air masses that form over tropical oceans are warm and moist. Air masses that form over deserts are hot and dry, and form over Arctic or Antarctic oceans are cold and moist. All right, and those are really the 4 types of air masses you can have. So we classify air masses according to their source regions. All right, for cold air masses, we call them polar because they start out near the poles. Warm air masses we call tropics because they come from tropical areas near the equator. Air masses that form over the ocean and are thus humid or moist are called maritime air masses, and air masses that form over land, which are dry, are continental. And so you can take a combination of either tropical or polar and mix it with either continental or maritime to get the 4 main classes. All right? Polar maritime, polar continental, tropical maritime, tropical continental. So it tells you polar versus tropical tells you warm, cold. Maritime, continental tells you moist, dry. Humid, not humid. Here in North America, we have 6 air masses that can affect our weather. All right? There are 3 cold air masses. All right? There's the maritime, polar, Pacific, which means it's maritime, it's forming over water in a cold area of the Pacific Ocean. There's the continental polar Canadian, which means it's a dry, cold air mass that forms over a good chunk of northern Canada. And then there's the maritime polar Atlantic, which is a moist, cold air mass that forms over the Atlantic Ocean. Down from the south, we have the maritime tropical Pacific, a moist, warm air mass that forms over the Pacific. The continental tropical air mass, which is a dry, warm air mass that forms over Mexico and the deserts of the southwest. And then there's the maritime tropical Atlantic, which is a humid, warm air mass that forms over the Caribbean and some of the Atlantic Ocean. So we hit all 4 of the types of air masses, and they come from those 6 regions. And typically an air mass brings weather of its source region. So if it's a warm, dry air mass, we get warm, dry weather. If it's a cold, dry air mass, we get cold, dry weather. So the cold, dry air mass can become more warm and more moist as it moves from land over a warm ocean. So the air masses can change over time depending on how fast they're moving and how long they spend over new landforms. The continental tropical air masses that we see form over the deserts of the southwestern U.S. Right? They bring dry, hot weather in the summer. They tend to not form in the winter because there's not as much sun there. Right? The maritime tropical air masses, they form over the warm waters of the Atlantic or Pacific Oceans. All right, and they bring hot, humid weather. If we were looking at dry, hot weather, we would be looking at a continental tropical air mass. Continental means dry. Tropical means hot or warm. The polar air masses are like kind of the opposite of the tropical ones. Instead of being warm, they're cold. They form in 3 regions: northern Canada, the northern Pacific, and the northern Atlantic Oceans. In summer, we tend to get a continental polar air mass, which will bring cool, dry weather. In winter, we get very, very cold weather. So a lot of this weather we've been having now, when it hasn't been snowing, although some of our snow has been lake effect from this cold weather, but whatever. We've been getting lots and lots of very frigid, cold air, and that's because we're getting the polar air, usually a continental polar air mass coming down from northern Canada. The maritime polar Atlantic air mass is a weird one. Usually, it heads east toward Europe. But every now and then, they tend to move westward, and they move over New England, and move over eastern Canada, and they bring cold, cloudy, snowy weather. If you've ever heard of storms called nor'easters, these are coming from that maritime polar Atlantic air mass. The reason that Boston, New York City have gotten so much snow this year is we've seen a big push from that maritime polar Atlantic air masses coming over and interacting with the northeastern U.S. In summer, we tend to get cool, low clouds and fog from these maritime polar Atlantic air masses. We don't really experience the maritime polar Pacific air mass because that's at the other end of the country. It has to move across the entire country and go over the Rockies, where it will lose a lot of its moisture. And those are the air masses, and what air masses are, and what kind of weather they bring and how they form. In the next lecture, lecture 2 of this 11th unit, we are going to talk more about what happens when 2 air masses interact with each other. What happens when a cold air mass and a dry and a warm air mass interact? What happens to the moisture as air masses interact? And that interaction between different air masses is really what creates most weather. So bring in any questions you might have, and have a good night.